Hello and welcome to our session. My name is Clive Couldwell. I'm Group Editor of Electronics Weekly. Today's roundtable will be available on demand after our live session, and it's accessible through the same link you're using now. However, we'd love to hear from you today, so do text in during the presentation, or discussion rather. If you have a question, please feel free to send it through the Ask a Question tab at the bottom of the page. And if we don't get to your question today, we'll be sure to follow up. And finally, we'd like to encourage you to share today's session with your social networks. We all like to be social. Now then, security is a key issue for IoT companies. Regulators are stepping up their game, developing and enacting legislation that holds IoT developers and ecosystem operators to account for the impact of the systems they implement. So what do we do? Well, to discuss next steps and get advice about the actions we should be taking, our three guests should have all the answers. Shahram, Mossyebi, CEO and co-founder of Crypto and Quantique, Vijay, Krishnan, General Manager of RISC-V Ventures at Intel and the project owner and lead for Pathfinder, and Mike Eftimakis, Vice President of Strategy and Ecosystems at Codasip. Gentlemen, it'd be quite nice if you can briefly give us a line or two about yourselves. Shahram, do you want to kick off?
Of course. Thank you, Clive. Hello, everyone. I'm Shahram Mossyebi, CEO, co-founder of Crypto Quantique. So my background mainly is around physics and cryptography and post-quantum cryptography before co-founding Crypto Quantique in 2016 here in London in the UK. What we do, the vision of the company is about securing the connected world with zero trust. And we're realizing that through unique identities per device and providing a platform for cryptographic tasks to create the first layer of trust for any connected device.
Okay, thanks, Shahram. Vijay?
Hi, this is Vijay here. It's great to be attending and participating in this event. I've been with Intel for over 25 years now, across many different geographies and job functions. The last year and a half or so have been dedicated to work around RISC-V. And for those of you who aren't aware, Intel has made significant investments in the RISC-V space and has also made some announcements along the way. So super excited to be here and looking forward to this discussion.
Well, we'll see what excited to have it. Thanks, Vijay. Well done. Thanks. Mike.
Hello, I'm Mike Eftimakis. I work with Codasip, which is a company that is proposing a different twist on the RISC-V CPUs. Instead of just proposing RISC-V IP like normal processors, we also have the ability of customizing them through the use of tools that help our customers get better results. So that's mostly what we are doing. Personally, I've been in the industry for almost 30 years, working in silicon companies and also IP providers. So happy to be here and talk with you.
Well, thank you all. Very good to see you, actually. We've probably got the three best people on the planet here to discuss this, so let's kick off. It might be appropriate, really, to start off with the first question. What's the current state of IoT security? Shahram, do you want to take that one?
Sure. So what we've seen in the past couple of years is a speed up into digital transformation in the industry and businesses, especially during the COVID and the pandemic, that is speed up. And that meant investing more into the IoT and connected devices to help with that digital transformation. But then in turn, that industries started facing challenges when it comes to security because of the, lack of clarity about who owns what part of security, who provides which bits of security, the confusion between IoT security and OT security and things like this, which meant in the past couple of years, we've seen increase in cyber attacks. Basically, the cyber attacks got doubled year on year in the past couple of years. So it's been a challenging journey, and kind of still security is being mentioned as the biggest headwind for scaling IoT in the ecosystem and in the industry. The biggest challenge is for the complexity of achieving IoT security for different entities involved in this really complex ecosystem around the IoT, and the lack of clarity. As you mentioned at the beginning, though, it's not all doom and gloom. So since 2019, we've seen governing bodies and governments started producing guidelines or regulations and standards, and a lot of them started to be deployed in the past couple of years. And from 2023, for instance, new ones in Europe will be enforced. And countries like UK, US, Singapore, EU are really leading those initiatives to create more clarity, basically, for people to understand what do they actually need when they talk about IoT security. What's the bare minimum that needs to be there for them to achieve the least? And then depending on the type of application or devices that they are using, then they can see what else they might need. So still challenging to achieve, in my opinion. Still a lot of education requires for the industry to understand where they stand and what they need. Still a lot of work within the ecosystem to take responsibility and actually do their bits to put the features into the products. But I see the light at the end of the tunnel because of the standards making it clear how to achieve different level of security for your device, and then we'll enforce that in a year or two across the globe.
Vijay, I mean, how important is IoT security to Intel? A bit of a silly question, I'm sure, but it seems such an important thing. But here we are with all these threats and cybersecurity. I mean, where do you start?
Right. So I think Intel has always sort of invested in and participated in initiatives related to security. If you look at our product portfolio, for the most part, we've led the way with new features on security and so on. And so Intel, for most people, our traditional business is actually building physical silicon. So we're a lot of, I think the thing that people most associate with Intel is that we're a processor company. But then I think when you look at security, it goes beyond just being a processor. Security needs to be implemented in a much larger scale. It needs to be include practices that take place in end user organization. It requires a handshake across hardware and software. There are many different elements that come into play. And one of the things that we at Intel sort of really believe strongly in is that we need to play our part. We need to invest, we need to collaborate, and we really need to drive awareness as well. So, not surprisingly, when we set out on our journey on RISC-V, one of the early associations we happen to have is with Quantique. And when we launched on the 30th of August, our Intel Pathfinder for RISC-V as well, Quantique was one of our initial partners. So I think, we try to practice what we preach, what we know is needed for security. We also try to make sure that we can provide that for our customers, either directly or through partnerships.
Okay, Mike, this is coming very much towards you, isn't it, really? Collaboration is quite important, isn't it? But especially if you're, developing, have this development environment of yours, which sounds quite interesting. We'll go into its detail a bit later. But what's your view of IoT security at the minute?
Well, it's interesting what has been said, and I fully agree with that. What I would say as well is that, in fact, security is needed because you start connecting things that were not connected in the past. Like you have machines now that are connected that used to be completely separated and more secure because they were not connected to the network. Like, well, let's take automotive, for example. Now we have cars connected to the web or to the cloud, I would say. And it's dangerous because these devices have been designed years ago, and at the time that was not a consideration when the design of the car was done, to have security within the car. Now it becomes really important. So in fact, what needs to be understood is that security is something that needs to be integrated from the start, from the beginning of the design, to make sure that you have a really secure solution. And as Vijay pointed out, it's not just a question of adding an element in the system. It's a complete system story with hardware working together with software, with practices, with processes, with services to make sure that you have a secure device. So it's not just a bit of security that you add to your solution. It's something that needs to be integrated, thought of, architected from the start, and then you can get something secure. So that's why we see so many attacks at the moment, because, well, most of the devices have not been thought out with security in mind. So that's really what I see as a big problem of IoT nowadays. And it's also one hope for the future products, because now that we have published good practices, we know what needs to be done in systems to make them secure. It's easier for product developers to really integrate that from the start and then design security in their systems.
I mean, you know, the more you think about security, it seems an obvious thing, doesn't it? But actually, when you start to think of the practical realities of how you accommodate, how you get people working together and tackling the different complexities of modern technology and how it fits together these days and its use. I mean, you could see this coming a mile off, couldn't you? But actually, the practical element of how the market's working and how development is proceeding makes the whole thing. Suddenly you wake up in 2022 and thought, well, this is our big problem and we should have seen it coming, but how, you know, there's nothing really in place and we are so vulnerable. In fact, it's the vulnerability I find quite worrying right across the board. Everyone I talk to, security is not my bag. It's really not my responsibility. I thought, whose is it? You know, where are the guidelines that we should be really looking at and observing? Where are they? And this is why it's sort of, I always thought, it's not a particular surprise to me why hardware security is important. I mean, I would always go to the hardware rather than software, even though we're in a software environment, as I'm sure you'd agree, Shahram. I mean, why is hardware security important? I mean, it seems an obvious question to ask in my view, but it'd be good for you to reiterate it.
Well, because everything starts from the hardware. You cannot have an IoT device without having the hardware. You're running your software on a piece of silicon. And security is in a way that if it doesn't come from your device, then it just makes it harder and harder to protect it. So it just makes sense to, like us human that have identities and that's unique to us and it can be verified easily through that identity, create a unique and unforgeable identity that comes from the DNA of your device. So then no one can claim it. And once you have that, you can always prove that this device is yours or this device is the device that you're supposed to communicate with. Otherwise, it will be very, very hard to achieve that if you're just relying on the software side. So going back to the points that Mark just made, first, security needs to be by design, not a bolts-on after the product is built. But once you do it by design, then that means you need to think about the very, very first step. That is the ICs, the silicon that goes inside the device. That's where everything starts. So that's where you need to think about security to start with. Then you need to provide the features that then later the software side can come and create a gap, create a bridge between the silicon to other applications and services, et cetera, et cetera. So that's why it's very important. Otherwise, it's just impossible to achieve security. It's doable. It's very, very hard, and it's flawed. But if you have hardware security, then you can build on it to create a bridge between the device and other applications and services.
So there's the question: why can't it be fixed with software and make that redundant?
Well, it doesn't make it redundant. It is important. So when especially about the IoT, when you look at it, it's not just hardware security or software security. It's hardware and software security. They need to work hand in hand. Otherwise, you cannot achieve security. And that's one of the biggest problem right now in the world, because if you just Google IoT security right now, you find thousands of companies all claiming they're solving IoT security. But in reality, they're either just providing a small piece of software for some sort of software security for you, or some sort of hardware security for you. There is no real end-to-end that considers all the challenges for a complex ecosystem and complexity of the application that runs on it to really address all the issues. So it's not either this or that. It's both together that solves the problem.
How do you define an ecosystem? I mean, all the ecosystems I have thrown at me are usually marketing led, and there's a sound commercial interest behind them. How do we tell how effective an ecosystem is technically? How do we know that it actually technologically is effective? Anybody can answer that one.
Yeah,
just throwing your weight behind that one. I'd like to be controversial whilst we're off.
Yeah, maybe I can answer on that.
Too cynical for my own good, but I have so much claptrap across my desk every 5 minutes. I'm over egging the pudding here. I know security is a really different thing, and I don't want to insult people. I'm a mere minion in the presence of you all here, but it is quite frustrating, I have to say, and it's such an important thing, and it's such a complex working environment, development-wise, and we are still. I'm amazed at how vulnerable we are if you look at it more closely. Are we ever going to find a solution to this, and how are these ecosystems going to be effective?
Yeah, that's one of the difficulties right now, because no single company can have a full solution, because solution covers everything. Security is a chain, and it's as secure as the weakest link, right? So it needs to be an assembly of solutions, or piece of solutions coming from different companies who are experts in this area, and basically the best solution will be to establish partnerships between companies who are complementary and who offer different pieces of the puzzle, and make sure that we interface correctly to build a trustable solution together. One thing I'd like to note as well is that this is not a standard off-the-shelf solution. Security will be dependent on the type of product you build. If you build a smart lock on your door, or if you build, I don't know, a car, the security requirements will be very different, and the threats that will apply to them will be very different. So security needs to be built for that particular product, and the elements that you will put in the solution will have to be adapted to that. So there are some guidelines that we can define, but in any case, it will require from the product manufacturer or product designer a study of the threats that will apply to the product, and also what needs to be implemented in terms of mitigation or secure infrastructure for that product, so that the product will resist all the attacks.
Vijay, what do you think?
No, I think Mike makes some great points. I'll just add a couple of my comments here. So, if you look at one of the great phenomenons, at least for people who are geeky and within the technology industry in the last 10 years, is the rise of RISC-V as an architecture. And if you look at the rise of RISC-V as an architecture, it's all about being open and modular. It, in many ways, and I'm paraphrasing what other people say, it democratizes chip design. So here you have an architecture that really opens the doors for all kinds of companies to go out and build silicon. And then you have that on the one side. So think of it as the wild, wild west. Everyone is getting in. People are building new, innovative silicon. And then on the other hand, you have this concern of security, which is all about being structured, have process. And so it's really, you talked about ecosystem. I think the ecosystem in the RISC-V space must come together. And I think, it is, I think there are lots of steps being taken here where people are coming together, because collaboration and structured collaboration is one of the unique reasons why RISC-V, despite being so open and modular, is still something that continues to progress and make meaningful progress with velocity as opposed to just speed. And I think it's fascinating how things do come together when people collaborate with the right mindset, which is to solve end user problems. And I think to me, it's a tremendous opportunity here for the ecosystem at large to collaborate in a way where we actually make a difference to end user organizations and to people and all these devices, millions or billions of IoT devices that are out there. How do we secure them and how do we make things better? I think that's really the opportunity it's an opportunity of a lifetime, frankly, that we all have. So I think there are enough motivated people here, and if we can work together, I think it's a tremendous accomplishment that's waiting to happen.
Well, and you have a great you have a great example here because Intel, Quantique, and Codasip are collaborating in this area, for example. So that's a good demonstration.
Absolutely. And adding another point, especially to what you said, Clive, that is frustrating, that security seems to be kind of, you need to have it. It's a simple thought, but people just ignoring it. I think the mindset around security needs to change a little bit. People just thinking about security as I need something to protect me, which is true. But also you can look at it as if I have security, that will enable for me to do other things that then essentially I can monetize. Simple example on, I don't know, mobile devices is the security on the chip, on the mobile device enables other secure app to run on the phone. So then other businesses can monetize from it, for instance. So that's a simple example. But that's very much the case for most IoT or connectivity applications. The security can enable and open other opportunities at the end user side, depending on the industry, etc. And people need to realize that sometimes it's not just I'm securing myself or my users. It's about I'm actually enabling other applications and opportunities to monetize.
So arguably the most important reason for being associated with the RISC-V group is really sort of advancing effective solutions for security, really. I mean, that in itself is probably the most important reason.
I think for us, I mean, obviously we are very proud to be the first root of trust on Intel Pathfinder, basically providing the level of chip and IoT end-to-end security for RISC-V on Pathfinder at multiple layers. The way that we're proud. One is obviously we've been chosen by Intel. It's a great credibility for us, and we're very appreciative of that. The other bit is it gives us this opportunity to actually be involved from the very, very beginning, security by design. So promote the security by design for any RISC-V chip design that is happening out there. The other aspect of it is we can now advocate for the benefits of what this security can enable for you as a chip vendor now. So if you compare a new chip vendor building RISC-V based secure MCUs or CPUs, they need to build infrastructure such as HSM infrastructure and other things in order to achieve that level of security for their products. That is very costly. Through our product and collaboration with Intel, they don't need to do that anymore. They could literally divert that investment into other things that helps their product to flourish. So we enable these things and we can enable the customer to have a better investment and actually monetize on the security that they add to their devices. And then also make it simple for their customers to achieve end-to-end security if the device is a connected device. So that's why partnerships such as or platforms such as Pathfinder is very, very valuable for us because it enables us to interact from the very, very first step with people. So then we can advocate the value of security to them from that stage.
Well, the point there is trusted partnerships, isn't it? I mean, to be open and collaborative, it requires faith in the people you're working with, doesn't it? And that's always been the case for all these years ago. I went to launch a RISC so many years ago. So how on earth is this going to develop in a really tough, competitive commercial environment, especially when designs and everything else are breaking boundaries about what's expected of them and how the technology is going on, how on earth can you keep on top of such a complex subject like security when other elements of consideration are in and people are competing with each other? Everybody now it's a worldwide market where everybody's got a different idea on how they operate. We've got the Chinese in play and everybody else, and it's you don't know. Quite frankly, you don't know who to trust, do you? Yet you have to be open and collaborative in order to move forward and break boundaries and actually do things that we need to do in an environment that, unfortunately, sometimes bears us to openness and insecurity. It's always been quite a dilemma. So running an organization that allows that to happen is something of a challenge in itself, I would think, but it has to be there. It's a question of at what cost. But it's interesting, isn't it? I mean, I haven't come across Pathfinder, I must say, but Vijay, what was Intel's interest in RISC-V in the first place? How did you get going?
Right. So I think two characteristics for us that are important about RISC-V. First is it's an open architecture, and Intel has always put its weight behind open architectures because we think that really drives proliferation based on standards, based on the ability to collaborate, and drives at the end, for us, a demand for our products. So frankly, when we want to serve the market at a global scale, and if you want computing to advance, one of the ways that happens is through open architecture. So I think Intel's always, through its history, tried to support open architectures. But then the second, quite frankly, is just related to the meteoric rise of RISC-V. I mean, if you go back 10 years in time, it didn't exist. And here we are, RISC-V is potentially, I would say, a third mainstream architecture in addition to x86 and ARM. So, that kind of pace is something we've never seen before. I think companies large and small, you just have to scan announcements over the last year to see who's doing something related to RISC-V. And so I think that really sparked for us. We wanted to be a first mover. We wanted to participate and collaborate as opposed to stand on the sidelines. Now, for Intel, how we participate is also something that is kind of a complex question. So we chose, as one of the early initiatives we would go into, was really Intel Pathfinder for RISC-V. And we focused there on sort of the pre-silicon development work that must take place for RISC-V to be realized in silicon and then, in actual deployments. And as part of what we did in Pathfinder for RISC-V, I think the one thing we stopped ourselves from doing is to be really operate as a silo, try and build something by ourselves and do it alone. That really would not have been in the right spirit and frankly would not have been successful anyway. I think we chose, I'm glad in hindsight, we chose a path which was all about participation and collaboration and doing it together with the ecosystem. So even as we launched, Codasip is a partner providing RISC-V cores and some of their capabilities. I mean, that's exciting. So, you have an Intel Pathfinder platform that can expose for a customer that's still in the early stages to be able to see what's possible on the Codasip front. And similarly with Crypto Quantique, they can, at an early stage, see what's possible there. From my perspective anyway, I think, we're kind of doing three really important things with Pathfinder. The first of which is trying to bring an ecosystem together and showing what's possible when you combine all of these different capabilities, including ours and our partners, right? So, I mean, we don't have it all either. So we are a small piece, as is everyone else. But Pathfinder is one of those ways in which we actually come together. The second is, how do you shorten the journey? How do you make it easier for a customer to go from a concept of a product to an actual shipping product? And so in that journey, we see ourselves as being hopefully a valuable catalyst that can actually accelerate that journey for a customer. And then the third aspect of it is around building confidence. So at a pre-silicon stage, how do you show proof of life to a customer and in a way where they actually have the confidence to say, yep, I'm going to bet on this and actually going to go out and deploy it in volume. So I think, those are some of the characteristics I think that are important for me. And of course, this is not the forum where we go into the nuts and bolts of Pathfinder for RISC-V, but hopefully, Clive, that gives you a flavor.
Yeah, it's quite a challenge, isn't it? Exciting at the same time, but somewhat challenging. Mike, how is Codasip prioritizing security then?
Yeah,
I mean, as a founder member of the RISC-V Foundation, and
yeah, exactly,
you've got a nice tool for auto tailoring now, haven't you? So that it's called Studio, I think, isn't it? Quite interesting.
Yes.
Anyway, I'll shut up now. Carry on.
Yeah, sorry. In fact, Codasip is one of the founding members of RISC-V, and one very important thing about RISC-V is this ability to be flexible and to adapt to the actual needs that you have. Instead of being a fixed instruction set that you always have to follow and you have to put everything in your processor and you can't change it, you have this ability to select which extension you want in your instruction set. So if you want, for example, floating point, or if you want other types of extensions, you can add them. They are standardized. You can add them, but you can go even one step beyond, which is absolutely impossible with other solutions, other standards, which is that you can add your own instructions in there. And that's the link with security, because in this case, for example, we have done, and we have worked with Quantique on that. We have done some trials, some demonstrations to show that the addition of some dedicated instructions can help significantly accelerate the security operations that are needed to implement some algorithms. So that's one example where the flexibility of RISC-V joins the security world and can help implement security at a lower cost, because that's always the question, right? How do we make it cheap enough so that people don't try to cut corners on security? And I would like to say also that in fact, for us, this is really where we differentiate as well. So that's one reason why we promote the RISC-V standard, because that helps going to a different paradigm for computing, where instead of just having fixed CPU that computes with standard instructions, you start to do an optimization, co-optimization of hardware and software together. And this is the next level of evolution, I would say, after all the scaling that we got through the technology, which is now slowing down because of end of Moore's law, etc. This is the next step where you can start to gain back your performance and gain back some capabilities for improvement. So it could be in security, but it could be also in other needs, for example, raw performance, and that's something that will be in the future very important to be able to gain without the gains that you can get from technology.
It's very difficult knowing which development environment to back, isn't it? In a sense. Also, one question that sort of seemed to arise is, how many ecosystems are we looking at here, generally speaking? I mean, you came from ARM, didn't you? There are clear differences around the two ecosystems there, but how many ecosystems are, and how many are they all competing with each other? And if I'm looking in on this objectively, where do I go? Who should I collaborate with and invest in? And that to my mind is a little USP from that point of view would be quite useful.
So you want my answer first? Okay, I can. I've worked with ARM in the past, so I can comment on that one.
That's what I'm thinking. Yes.
Yes. So what is important to note is that there are two types of links, I would say, in an ecosystem. Ones that are kind of exclusive, So if you work with ARM, you can't, the solution that you have assembled cannot work with RISC-V, for example, and others that are non-exclusive. And for example, if you have some security functions on the chip that could work with any other processor or any other system. So there's a lot of things that can be reused from the ARM ecosystem for the RISC-V ecosystem. There's a lot of elements that can be reused, and it can go from hardware elements to software elements to even practices that are similar, because the concept of security, the methodologies, etc., they are strictly the same. It's how you want to implement that in your system, what kind of performance impact you will get on your system that will help you take the right decision and see which partner you need to have for your security. So I would say,
this is my thing, really.
It's not black and white.
The security, it shouldn't be the sort of control of any one domain or ecosystem. It should be widely shared, and by all means, carry on with your commercial developments and everything else. But you can see where the brick walls are starting to build, can't you? It's go with them. You won't be as secure as you are with us. But there is this tool. We've reached so far now that security is a bit of a sacrosanct subject, and therefore should be available to everybody. We should be sharing everything, and by the very thing, the whole thing elements of what we're developing should be open. We have no choice. It has to be, because it's such complex, and now we're in a different world completely, and there's so much integration, overlap, and so on, that we're all as vulnerable as each other, and therefore we should be sharing certain labeled information that will help us keep us all safe and secure and everything else. I'm not sure whether that's my little world, my view of utopia, or whether I'm sitting in a very different. I've ridden about security with donkey's ears and seen it go nowhere, and always at the bottom of people's. Now we're in that thing within electronics community where it's utterly crucial to our next step onwards, and therefore needs to be addressed in a much more sophisticated way than we've hitherto done it.
I think security can also be democratized, as Vijay
Thank
mentioned.
You for saying that, Shahram. That's what I was trying to say in a very long around way of saying it. Yes.
One of the bits that really attracts me to RISC-V is the fact that it democratizes access to compute, rather than being just at the mercy of one or two other companies. You can actually now, especially through Pathfinder, just choose this wealth of different vendors, whether it's Codasip or others. They are just there for you with their cores, and you can choose from them which one you want to do with them. I think the same concept for security can also be provided. And security traditionally also used to be, or still is, a kind of a big brother type environment, that someone owns everything and just gives the bits to you that protects you for what you want to achieve. But it absolutely can be democratized, and people or the vendors can be in charge of their own destiny when it comes to security, and control the privacy of the data and their own security if it's done right. And that's one of the things we have achieved, I believe, at CQ, the way we designed the product. That we can give the whole thing to the end user. They could run it for themselves, and we just behind the scene can support the security aspect for them. But once they set up the security or integrate the security into their product, they are the owner of the main bits and the key to the realm compared to anyone else, including us. So it can be democratized and should be democratized, I believe. And that also address that trust that you mentioned. I mean, you don't need to trust other people's if it's open source and is under different platforms, and you can work with different vendors and you can take control of it, then the trust issue also will be addressed.
Okay, which brings us on to Puff. Do I say PUF or is it Puff?
Well, we usually call it Puff, yes.
Okay.
It's a funny name, but yeah.
Now, there are two types of Puff, aren't there? You've got one generation of Puff technology, haven't you? And I have to say, I love the idea of it, but I'm I mean, it should be a game-changing environment, isn't it, in IoT security? But I'm not sure which is better, one version that you've got or the other one. I don't know. So I don't know enough about it to.
Sure.
So
I guess it's
what is it? How is it? What are its benefits? And in a sentence or two, why should we be considering it?
Of course. I mean, PUFs, or physical unclonable functions, been around since 2000, early 2000s. Basically, the idea is you can create sort of unclonable randomness from the fabric of a device based on how an electronic device is built. So that will be unique to that device. Then the question is that randomness that you have created is good enough to do security with. And that is the point that kind of distinguish the first generation from the second generation. The first generations, we believe, they just look at the primitive electronics that are out there and try to just harness what's inside them, even though that electronic component supposed to provide another functionalities. For instance, is a memory or ring oscillator or other things. We built something from scratch in order to actually look at some variability inside the silicon, and then in a way that we can reliably harness it, and that will give us a high quality, high entropy randomness that is reproducible through the same device and same process, but at the same time is unclonable, unique to that device, and also secure against side channel attacks known to electronic devices. So that's why we call it second generation. And what we've done is we basically reading quantum tunneling currents in silicon devices in order to create that randomness. And then through that, what we do is we create cryptographically verifiable identities for those devices. So each device will have a number, but that number is not just a random string, is a number that cryptographically can be verified by a verifier, which could be a cloud service, or also can be proved by the device, whatever that device is. So that's the kind of a big difference. So PUFs could play, and as we kind of designed it and integrated into a bigger system on the software side and embedded side, can play a very, very crucial role into creating unforgeable identities per device that then enables us at any point of time authenticate the device to know that we're talking with the device that we're supposed to, but then afterwards at any point of time enables us to attest the hardware and the software that runs on it. And that's a very, very important point that you can achieve for any connected device.
Okay, how easy is it to integrate into silicon?
So our IP is a normal silicon IP, and we have it in multiple process nodes right now, from 55 nanometers to 22. Hopefully soon we're going to go to lower nodes for more high-end devices. Our IP is a mixed signal IP, so it's an analog IP, but everything is contained, and you just drop the IP, given the complexity of designing an analog IP into your design. But it's a simple, basically silicon IP that you put inside your design. So nothing extraordinary about it.
Are there any tools that chip designers can use?
Yeah, I think we use both, all the main EDAs, basically, whether it's Synopsys or Cadence or Siemens, doesn't matter.
And do you conform to any standards at all, international or national?
So the IP has been tested by third-party security labs against common criteria standards, for instance, and things like that, and proven to be secure and be ready. And also we have PSA level 2 readiness as well.
Okay. Yeah, I must maybe add something here,
Sorry, yeah.
which is that from our point of view, Codasip, we provide the processes, but for us it's really important to find the right partners for security, because very often our customers ask us, okay, what do I need to get a secure device? And of course we provide a bit, but we need to have good partners to point to say, okay, well, if you need a PUF, for example, go and talk to Quantique. So for us, this is what we do in terms of security. Really being able to assemble a network of partners around us to have this good reference and good elements that can build a secure solution.
How big is this network going to grow into? I mean, who are you looking for at the moment? Are you on the hunt for the perfect partner or collection of them? I mean, you've got Intel in the mix here, a pretty powerful partner, I would say.
We do want to make sure that the partners we reference are really able to provide a good solution. And there has been a mention that there are a number of providers in the market. Some of them have solutions that are not great, and it's good to be able to do some kind of filtering in this to be able to recommend the right ones. So for us, that's our main target for now, making sure that we are able to recommend the right partners, and also, of course, start doing some integration work or demonstrations to show the IP working together to give a head start to our customers.
Gentlemen, what security challenges do we face over the coming 12 months or so? Things that we should be aware of that you feel you're going to be able to make a mark on and plan ahead for? Vijay, what about you?
Yeah, so I think, so Clive, firstly, I think security is one of the big investment areas for us within what we're doing in the RISC-V space. So I think it happens to be something that we really care about. It's certainly difficult for me to talk about what we're planning going forward, because that gets into the confidentiality space. But I think that said, I think what we do want to do increasingly is, when you look at security, like in some ways, like other capabilities, there's what you can do as a standalone capability, and then there's an aspect of how you can operationalize it in a connected world with heterogeneous architectures and complex deployments with cloud, etc. And I think one of the things that we want to do increasingly over the next year or so is provide for that confidence. So in the pre-silicon stage, how do you show a customer what's possible? For example, it may be instantiated on a large FPGA board with lots of wires hanging off of it and all of that, but the important element is, especially speaking from a Pathfinder standpoint, how can you show a customer that you could actually enable a bunch of capabilities right there and have this big clunky device, though it may not be your final deployment device, but that same functionality is available and can actually connect to for example, your IoT cloud services and participate as yet another entity showing you what's possible and how that device would behave in your larger context. That I think is extremely powerful. And I think as part of what we're doing there, you can have the RISC-V cores, you can have the security capabilities, and even, for example, additional capabilities in software. One of our other partners is Checkpoint, a leading provider of cybersecurity solutions. So one of the things we really want to make possible for users is make it much easier for them to be able to enjoy or to be able to demonstrate all of this in a physical device that connects to their overall infrastructure. Because that, I think, just shows proof of life of the capabilities. And once you do that, that opens the doors for investment, for rapid deployment. I think that's sort of where we are headed. Just being able to show proof of life, show the capability as early as possible in the life cycle of product deployments or development and deployment, I should say. And through all of that, accelerating the adoption of secure, RISC-V based IoT devices.
Sounds promising. Mike, like to add?
Yeah, well, I can predict without...
Said it already, hasn't he, in a sense?
Yeah, I can predict without too much risk that you will hear about new attacks on IoT devices in the coming year, and that each time companies will start, well, especially companies building products, so the companies who use chips will more and more realize that it's a huge risk to their brand, to their reputation, and they will impose more and more requirements on the chip vendors. The problem for the chip vendors is that it takes time to build a new chip with security in, etc. So if they are not prepared, then they will not be able to answer these requirements, and their products will not be sold, their chips will not be sold to these product manufacturers. So it's important for chip vendors to all realize that security has to be built. If it's not the case right now, it has to be integrated immediately in their solutions so that they will be able to sell something in a few years' time. If they don't, then they will become irrelevant because all product vendors will require security. And we see that already with the cloud vendors. Now, some cloud vendors start to say that they won't allow any device that doesn't have security to be connected to their cloud because it's a danger, it's a risk for them. So, so security will become a must-have capability for chip vendors and for product vendors. So it's really important for everybody to understand that and not say, oh yeah, well, security is an added cost, or I don't want to do it. No, it's not the question. You have to do it. So it's how can you implement it at a reasonable cost and with the reasonable functionalities that are needed in the future products that your chip will enable. So that's the right question. So I guess, well, governments, as you mentioned earlier, governments will continue pushing for additional security, but the most important drive will come from the product vendors, the product manufacturers.
Final words from you, Shahram.
I think I'm just gonna say a couple of things. It's people need to pay more attention to security by design. The reason is it either saves them money or actually makes them money, and it's something that people need to realize when it comes to security. And then the last thing I would say is security is one of those things that you should not try it at home because it's very complicated. You need to leave it to experts, and there are so many painful examples out there that with all the respect to engineers, they thought they got it and they know how, I don't know, public key cryptography works or what algorithms and the other algorithms, and they just messed it up because it's way more complicated than they think. So leave it to experts, but pay attention to it. And it's more than just I'm securing myself or my client. It could open up other business opportunities. So you just need to look for it.
Brilliant. Well, Vijay, Mike, and Shahram, thanks very much. Thanks for putting up with me, Mr. Noddy, compared to you three. Fantastic. I think we covered quite a big area there. Wise words, actually, I have to say. Thanks very much for saying them. So thank you for being with us today. And if you haven't managed to get through with your questions, rest assured we will get back to you as soon as possible. But goodbye, and thank you for watching.
Thank you for having us.
Thank you.
Thank you.